All right. So in this chapter, we'll be talking about personal data, organizational data, tax and cybersecurity professionals, cyber warfare. So let's move straight to personal data. So first off, we need to understand what cybersecurity is, right? So from our introductory section, we talked about cybersecurity, and it's like the protection of systems, uh, organizations, networks, okay, protecting the data actually from all unauthorized access. So protecting your personal data from unauthorized access. All right. So your online and offline identity is what is being protected by cybersecurity. All right. So you have your identity that interacts on a regular basis at home, school, or work. That is your offline identity. Then your online identity is whatever represents you while you are in a virtual environment or in an online space. Okay, just like your social media, that's your online identity. Your social media account is an online identity. Okay, and this online identity uses what is called your username or an alias. So your personal data now also includes uh, medical records, electronic health records. Okay, electronic health records are examples of medical records. Okay, we have physical, mental, and personal information. In our orientation, I was talking about an assassin. Okay, not necessarily in our orientation. Sometimes I was teaching, sometimes even I was telling someone about an assassination attack that can be carried out just by obtaining the person's health record. So you know what the person is allergic to, and you could just use that to attack the person just by the knowledge of the person's health issues. Or let me say someone that is asthmatic now, you expose the person to whatever will trigger an asthma attack, and the person can lose his life from there. And it looks as though it's an accident, but meanwhile it was an actual arranged attack. So other personal data could include your education record, employment and financial record. So where is your data? Okay, where is your data? We have medical records. So where's your medical record located? In doctor's office, insurance company, okay, and your company or your computer devices can also contain your own personal record. So things like your memory card, your internal storage contain your personal records. Remember that when you are accessing websites, your information are being stored on your particular browser. Sometimes some of us usually do auto-save passwords or maybe save passwords, and that's usually that usually saves our data on the browser. So how do criminals get your money? They do that by having access to your online credentials. Okay. So when criminals have access to your online credentials, they can access your wallet. Okay. Things like your ATM cards, your ATM pins. Whenever you add them to your browser, remember platforms like Google would always ask you to save your card on the web so that you can easily purchase things easily, without having to add the card number the second time. So when an attacker infects a website and you visit that website, that website can be infected with a virus that will actually get into your system and begin to feed the attacker with informations of everything that you're typing. So um, when you visit a website where you have to pay, so there are worms like keylogin worms or keylogin malwares that will give an attacker every stroke that you hit on your keyboard. So if you hit an A, the attacker gets to know that you have hit an A. So they have a log of every data you entered on your keyboard. So why did they want your identity? Or why would attackers want your identity? Long-term profits, medical benefits, file or fake tax return, open credit card account, obtain loans. Not everybody have access to large amount of loans like some persons, okay? But attackers would use your identity to apply for loans, okay? And when they get it, that loan will be requested with your identity. So it looks as though you are the one that actually took the loan, but meanwhile, someone else took that loan on your behalf. So let's look at organizational data. So there are types of organizational data, which is the traditional data, and it includes the personnel, okay, intellectual or financial data. So financial data, income statements, balance sheets, cash flow statements. The intellectual data is patents, trademarks, product plan. Personal data, application materials, payrolls, offer letter, employee agreements. So these are actual data that attackers might go for because these documents might contain personal information of the employees. All right. For example, nobody knows how much Mark Zuckerberg earns, but or how much goes into his account from his company, from Facebook. But when an attacker hits Facebook and gets this kind of document, they can publish that to the web, and before you know it, everybody knows everything about Mark Zuckerberg's income, and he becomes very, very insecure. So another type of organizational data is the Internet of Things, which is and big data. So some of you that usually browse YouTube, you see Google BigQuery is an ad that is very popular now. Google BigQuery that helps with small businesses organize their data. That's one thing that Google is big on, big data. Okay, big data is actually a cluster of, would I say, a house of data. A house of data that is being collected from the world overall. So every single data of every human being that have used a device and have visited Google before, Google has that data. So you can regard that to be big data. And that's one of Google's strengths, data. And if an attacker has access to a, would I say, big data that is related to your organization, that can be used against your organization. So imagine organizations that disobey rules. So another organization, let me say a rival organization can employ attackers to steal such information and use it against those organizations so that they can obtain monopoly in the market. So another thing is confidentiality, integrity, and availability. Confidentiality has to do with privacy. Integrity has to do with the trustworthiness of information or data that your company usually have or work with. Availability is the accessibility of information in your company. So I'll explain better because during this course we're going to look at confidentiality critically, we look at integrity critically, look at availability critically, where we now come to know the five nines concepts. So confidentiality now, organizational data are very, very confidential. For example, companies or bakeries that usually make food or cook or bake, they usually have their own recipes, and those recipes are confidential. Just so that some other organization or some other bakery doesn't get hold of that recipe and begin to produce an exact replica of what they have, and that's going to break the market share. So integrity now has to do with the trustworthiness of or the accuracy of a company's data. I'll give you an example of that. If there's a trend, or like I saw some post some time ago that ChatGPT is now giving wrong answers. Now that can happen if something like data poisoning happens. Okay, your platform or your organization will lose its integrity because of data poisoning. This is how data poisoning works, or this is how data work. Like say big data work. In machine learning and AI, there's something called supervised learning. So when I have five red balls and I label them as red balls, okay, and I label another three balls that are yellow as yellow balls. So when next I bring a red ball, the machine automatically detects it as a red ball. When I bring the yellow ball, the machine automatically detects it as a what? A yellow ball. Now when I bring a red ball now, okay, a ball that is actually red, and label it black and gives it to the machine as a data. So when next data is being fetched from that machine to decide or to tell each other whether this is a red ball or yellow ball or a black ball, the machine now at some times will give the answer as black ball, and the other of the times will give the answer as what? Red ball. That's because the data that has been given to that machine has been poisoned by identifying or labeling a red ball as black ball when a red ball is not supposed to be labeled as a black ball. So that's how the integrity of a company can be affected. So the next one is availability. A company's availability, a company's availability can be affected when their power can be shut down. Maybe data center has been breached or data has been breached, or maybe they experience a denial of service attack like DDoS. I played a video about a guy that attacked a company in our onboarding session, whereby after getting access to the company's data, he now wiped the entire data. So when next the staff usually wanted to access the data was no longer being found. It was like data not found, this not found, this not found. Now, at that point, the company can no longer carry out any of their services because they no longer have data to, give response to customers' queries. So that's an exact example of a denial of service attack, which we'll look at later in this course. So the availability of a company is more like the rate. So high availability means lesser downtimes. Okay. There was some time that Facebook, Instagram stopped working. I think many people experienced that. So that was a downtime. In fact, the last time that even happened has been very, very long ago. So when a company is being attacked, like a DDoS attack is carried out, the availability has dropped. Okay. High availability means lesser downtime. Low availability means higher downtime. So whenever your company is not always open, for example, an E3 that is not always open, or a filling station that is not always open, it means that filling station's availability is very, very poor. And there's a way to calculate availability, which we'll be discussing later again in the course. All right, so the impact of a security breach. There are consequences for security breaches, and it is not feasible to prevent every attack. Attackers will always find new ways. Ruined reputation, vandalism, theft, revenue loss, damage in the intellectual property are consequences. They are all consequences of what security breaches. So, an example of a security breach is like an online password manager, okay, that has been manipulated, or stolen email address, or password reminders. So these actually are examples of security breaches. So when you have an unknown person or um, an unprivileged access to data, or an illegal access to data, that's an example of a security breach. Now let's use a physical scenario for example. Not everybody is allowed to enter a security barracks or an army barracks. You're going to be checked from the beginning. Not everybody have not everybody not just anybody can enter into a bank with some kind of object. Although in Nigeria banks they usually allow people just go in their bag and all that. Normally every bank usually have some kind of safes outside that people usually drop items before they go into the bank. Just so that for security reasons. So he says that users should use complex master passwords. So change master password periodically and beware of phishing attacks. So a way to let's say remediate security breaches is by changing your passwords. For example, on my laptop, I have two users. I have the main administrator user and a normal standard user. So I no longer use my administrator account for anything. I usually use the standard user account, such that if an attack is being carried out on my system, or if something like a phishing attack is carried out, the attacker will only have access to all the documents, all the files that are on that particular user. Meanwhile, I keep majority or the bulk of my files for at my administrator account, and I use my standard user account. For example, for this class, I'm using my standard user account. So in case of any security breach, I don't have any loss of data. So I use the standard user account for public activities. But when I get home now and I want to, work on code, program, okay, work on my web page, or work on a project that has to do with programming and stuff that don't require me to go online. I can use my administrator account to run that, because most of the time when I want to install applications, I have to use the administrator account in order to allow that application to have administrator privileges. So one another way again is to set up things like MFA on your different accounts. You ask yourself a question: do your Google accounts have a multi-factor authentication? When I say MFA, I mean multi-factor authentication. Does your Google account have multi-factor authentication? In fact, the rate at which WhatsApp accounts are being hacked easily, it's alarming. So do your WhatsApp have multi-factor authentication? Do you have two-step verification for your social media accounts? So these are features that are set in almost all social media platforms. So let's look at another example, VTech. So VTech is a high-tech toy maker for children. Okay, So it exposed sensitive information, including customer names, email addresses, passwords, pictures, and chat logs. So VTech did not safeguard information properly. So hackers can create email accounts, apply for credits, and commit crimes using the children's information. So hackers can also take over parents' online accounts. Now you can see here, this is another example though. So when VTech, because VTech, it's children's stuff that they usually they did not take priority, did not take security as priority. In that way, they exposed several customer names and email addresses, passwords, and customer pictures. So when attackers come into such applications, they just have a proper look at the customer database easily, and they can just pick anybody's account, make a research on the person. Since they have the person's email, and some people, how careless some people can be, they use the same password for everything. Same password to their email address as the same password for this VTech account. And attackers will now have access to that email and use it to perform or make application for loans, or use it to carry out any cyber attack from any place. And it looks as though it's that innocent parent that carried out the attack. Or maybe use a child's own account to carry out an attack, and it's looking as though it was a child that carried out an attack. Another one is Equifax. So Equifax is a credit reporting agency. Okay, and attackers exploited the vulnerability in web applications in their web application software. So Equifax established a dedicated website with a new domain name that allowed nefarious parties to create unauthorized websites for phishing schemes. So you can see a very strong vulnerability here. This one is on the web. So when attackers got access to this domain, so they were able to create unauthorized websites, okay, to carry out phishing attack. So, so from this website, when you just visit, before you know it, you start receiving emails from unknown persons, or probably promotion emails that you might find very enticing, and you might have to click to download something or click a link to redirect you to a website. And once you just hit that link, immediately you are being attacked or infected with a malware, and the malware carries out whatever the attacker has programmed it to carry out. So let's look at attackers and cybersecurity professionals. So attackers, the types of attackers we have are just grouped into three. Okay, so we have amateurs, okay, which they can be known as the script kiddies. Now these amateurs, they have no skill. They just search online for tools and just test them out. Test them out on their neighbors, test them out on their friends, test them out on startups, just to have fun. So they just use existing codes that they find online to carry out online attacks. So we have hackers too. So hackers now, these are the good guys. These are the guys that are proficient with attacking or proficient with the skills. And they can be divided into two. We have white, they can divide into three rather. White hat hackers, gray hat hackers, and black hat hackers. Now, people that are called white hat hackers, they break into systems with permission to discover weaknesses so that the security of these systems can be improved. So these white hat hackers, they are the ones that are called ethical hackers. Okay, for those of you that would like to know about ethical hacking, so that's what ethical hacking is about. So ethical hackers are white hat hackers that will be given permission to just come. For example, I might own a company, or Spring Expo can have a website and now pay an ethical hacker to come and hack into their website, just so that they can know the different vulnerabilities that they have on their website, and they can attend to those security issues immediately. We have gray hat hackers. So this ones, they compromise systems without permission. Okay, they are just doing it for fun. Most of them, they just do it for fun. They just go cause problem and they move out. They go cause problem and they move out. Sometimes it might just be a vulnerability that they find out, and they'll just um, go ahead and cause a problem with that vulnerability. Then we have black hat hackers. So black hat hackers, they are the ones that just come, they scan your system, check for vulnerabilities, and they take advantage of those vulnerabilities. Okay, so they are illegal. They are illegal personnel. Okay, they are also called unethical hackers, and they do all their activities for financial gain or political gain, probably for just personal gain or personal glory. So that's it about the black hat hackers. Then now the last, would class of hackers we have is organized hackers. So These are organizations of cybersecurity criminals. It could be activists, terrorists, and state-sponsored hackers. When I say state-sponsored hackers, they could be hackers that are what sponsored by the state government. Okay, so a country can sponsor a group of attackers just so that they can carry out an attack on a country. So that's an example of a state sponsored attack or a state sponsored um, hacker. All right. So there are, sometimes it could be between parties. Let me say during election now. Okay, we have this that's where activists come into play. Maybe a party like let me say PDP now want to expose something about APC just so that APC will lose their followers. They will now go and employ people, a group of attackers or hackers to hack into APC's private files and start publishing things online, publishing records, medical records. They say that this person did not go to school, this person faked his certificate, this person did not actually do this, this person did not actually do this, and from there they can cause issues and people will lose integrity in the eyes of their followers. So now let's look at um, threats. Okay, we have internal and external threats. So internal security threats can be an employee or a contract partner. Now, when a threat is internal, it means that the person has access to the organization immediately, or has immediate access to the organization files, or has a direct access to the organization. So when a threat actor has direct access to the organization, that is an internal security threat. Okay, so maybe a staff, okay, mishandled confidential data or threaten the operations of internal servers or network infrastructure devices. Another type of internal security threat could be what facilitates outside attacks by connecting infected USB media into the corporate computer system. So another way that a direct or internal security threat can happen is if accidentally a staff invites malware into the network through malicious email or websites. And these attacks can cause great damages because it has a direct access to the organizational database, organizational files. But now, when a threat or a security threat is external, it means that the attacker or the threat does not have a direct access to the organization. So an example is social engineering. When an attacker just approaches a staff so the staff is not really aware that it's an attacker. So just by social engineering, the person is able to like convince the staff to carry out a particular task that he was not supposed to carry out. Or the attacker exploits a vulnerability on the organization's network. So the attacker can be operating from outside the firm, probably from his own house, and get access to the organization's network and damage or poison the organization's data, probably financial records. Poison by the time he poisons those data or changes or alters one or two data, that can cause a huge problem for the organization. Now let's look at the cyber warfare. So um, the cyber warfare is just a term that describes uh, attacks that were carried out and caused a global problem or is a national problem or a state level problem. And an example is the Stonex malware. So it was designed to damage Iran's nuclear enrichment plants. So it used modular coding, it used stolen digital certificates. So the Stonex malware was an attack that was carried out was um, channeled to Iran. Iran used to have a, a nuclear plant. Okay, so another nation was trying to like attack them. So that's an example of that. But let's look at the purpose of cyber warfare. So the purpose of cyber warfare was to gain advantage over adversaries, nations, or competitors. So chapter 2 talks about attacks, concepts, and different techniques. So we're analyzing a cyber attack, the cybersecurity landscape. Now let's look at analyzing a cyber attack. So you need to understand what an exploit is. So it's a term that is used to describe a program written to take advantage of a known vulnerability. So you see these things, these are things that you should become conversant with in the cybersecurity landscape. Okay, another is an attack. So the act of using an exploit against vulnerability. You can see the connect. Exploit is a program written to take advantage of a what known vulnerability. An attack is the act of what using an exploit against a vulnerability. Now let's look at the vulnerabilities that exist in software. It could be errors in operating systems or application codes. Now, there are errors, there can be errors in operating systems that can be caused by malware. For example, when you install a virus, that can lead to a total denial of service attack whereby your operating system will just crash. Or it can hamper your Windows security or whatever application you're using to as security for your device or your laptop. We have sinful knock, which is vulnerability in Cisco's iOS. So it allows attackers to gain control of the routers, monitor network communication, affect other network devices. So that's a software actually that can be used on Cisco routers to carry out attacks. Okay. Another one is Project Zero. So Google formed a permanent team dedicated to finding software vulnerability, and that team was called Project Zero, just so that they can limit the amount of vulnerability in software. So we also have hardware vulnerabilities. So hardware vulnerability can be regarded as the different flaws or the different disadvantages in the design of a hardware. Probably something physical. It could be a door. Okay. When you design a key lock, someone designs a key lock and instead of the original key that's for that door, some other key is able to open it. That's a hardware vulnerability. Hardware vulnerability can also exist in automated systems. Remember, doors are opened by themselves. Okay, so if a door that opens by itself uses a facial recognition system to open up, now when that system is no longer functioning, probably the hardware is having an issue. The door might just be opening for anybody and can give access to a an attacker. Okay, so an attacker can just have access to that what is behind that door for free, even without trying to manipulate the system. So that's an example of hardware vulnerability. So an example of that was used was row hammer, which is a RAM memory exploit that allows data to be retrieved from nearby address memory cells. So if you understand what the how the RAM works, you know that RAM has memory addresses and stores data in different sections of the memory addresses. So you have buffer overflow. Now, these are categories of security vulnerability. Buffer overflow. So when data is written beyond its limits of a buffer, let me explain. Remember I talked about the RAM. The RAM has a specific number of memory locations that it uses to carry or transport data from via the buses on a computer. So when data is written that is beyond what the RAM should be able to carry, that can lead to buffer overflow. That's just a layman's explanation. Another one is non-validated inputs. So when you force programs to behave in an unintended way, for example, trying multiple passwords on a passcode device that is supposed to work. Remember, okay, if you use this Nokia Touch, then that 3310, not 3310 precisely. There was all these Nokia Touch that had yellow light or blue light as their screen, that's blue and black. Now, if you set a password on those devices, when you open, when you type, when the phone is locked, you are permitted to still type numbers. So there's a way you can type numbers or call emergency. When you call emergency and you end the call speedily, you just type the end call several times. It's going to unlock the phone. So that's an example of non-validated input. So the input that you made was not validated and the phone was forced to unlock. Another one is race conditions, improperly ordered or timed events. Another is weakness in security practices, access control problems. So access control to physical equipment and resources. So access control has to do with people having access to, for example, only some staff have access to some particular doors in some offices. If you work at Huawei, then a friend of mine that did an internship with Huawei, they all have custom or staff cards, okay, that they use to access different places. So as an intern, your card will not work on some specific doors because you don't have clearance to pass through those doors. So if you would want to pass through those doors in any case, you would need the assistance of a higher level staff to use this card on the door so that you can have access to what's behind that door. Let's look at types of malware. Malware is used to steal data, bypass access controls, cause harm to and or compromise the system. So the different types of malware we have are spyware, adware, bots, ransomware, scareware. These are only a few. Remember I said this is just the introduction to cybersecurity. Later in the course, we are going to be looking at several others and looking at them in depth. Okay, we'll thoroughly look at spyware, thoroughly look at adware, look at how they work, look at bots, look at ransomware, how they work, look at scareware, how they work. Okay, so spyware just track and spy on users. So you can have a spyware on your system and you would not know. So an attacker can just be remotely having access to your system, watching everything you're looking at. Probably he has infected your system, so your webcam is automatically on, which you would not be aware of, and he will just monitoring you, your physical movement, monitoring you physically from his own house remotely. So that's how spyware works. So hardware works on websites, okay, and they usually come with spyware. So when you open a website and you see that there are several unnecessary ads, so it means that that website has been attacked, or has hardware infected on the probably the website source code, okay, that has been planted in the website source code. So bots now, on the other hand, are malwares that work on their own. They could be they work with most of them work with system files. For example, when you run an executable file on your system, let me say you download application. You download applications on your laptop now. It's always .exe, .executable. So once you run that application, if the application is infected with a malware, for example, a bot now. So once you run the application, the bot automatically carries out a number of tasks. Sometimes it replicates itself around the system. And when you run another application, it replicates itself again. So it just does performs an automated action. Then next we have ransomware. So ransomware holds a computer system or data captive until a payment is made. So I had a friend that once was attacked by this. So he had a ransomware in system. So all his files were encrypted. Even new files that he copied to the system, he got encrypted. And whenever I tried to open them, just a pop-up that was saying to pay some amount of money to some account, some kind of account. It was actually a wallet ID, so it was on the blockchain. So which means that account cannot be tracked. That's an example of a malware. So once he paid that money before he was able to access his files again. And first thing, he just wiped the entire system because he already had them backed up on his hard drive. Another one is scareware. It's just a way of using a malware to persuade the user to take a specific action based on fear. For example, you might just see a couple that says, if you don't do this, so thing will happen to your account. So you'll be scared, and people that are not so IT inclined will tend to fall for such messages or such pop-ups. So we also have rootkits. Okay, we also have viruses. We also have Trojan horses. We have worms. We have man in the middle, or man in the mobile. So that one is a situation whereby someone is taking charge of whatever knowledge is being passed from one person to another. So rootkit usually modifies operating systems such that it creates a backdoor on the operating system for attackers to be able to use to enter into your devices or probably your network. Now, most of the time now, this is one thing that usually gets people confused. They usually just call any type of malware a virus. A virus is just an example of a malware, a type of malware. Okay, so it's important that you understand that. So a virus now is a malicious executable code that is attached to other executable files. Okay, so when you download an application, a virus can be attached to that file. We also have Trojan horse. Trojan horse is majorly used most times to carry out denial of service attack. So um it just carries out its action under the by disguising itself as a desired operation on the system processes. So we also have worms. Worms usually replicate themselves. Now, this look at this. There's an image here. This image here is an example of a worm that spread around the world. Okay, so the worm just started from one person and it spread all over the internet. And this spread all over the internet in 19 hours. Before you know it, the worm was everywhere all over the internet. Let's go further. Let's look at the symptoms of malware. There's increase in CPU usage. There's a decrease in computer speed. The computer freezes or crashes often. There's a decrease in web browsing speed. There are unexplainable problems with network connections. Also, your files could be modified. You find that your files are missing, files could be deleted, or you see softwares or applications that you did not install on your system, you see them on your desktop. You might also see unknown processes running on your task manager. I'm going to show you how to check that. And also, programs might just be turning off on their own or be shutting down on their own. Or you see emails will be sent to different people without your consent. So your email will be sending emails to other persons without consent. So that's a symptom of a malware. So a malware is like a disease or a sickness in your computer system or your mobile device. Let's explain social engineering. This picture here explains typically what social engineering is. You can see a puppeteer controlling puppets. So that's exactly what social engineering is. So social engineering is just the manipulation of individuals to perform actions or to giving out confidential information that they are not supposed to. And this can be done by what? Pretexting. So an attacker calls an individual and lies to them in an attempt to gain access to privileged data. Another one is tailgating. This is where an attacker quickly follows an authorized person into a secure location. So this is actually physical. Okay, this one is physical. It happens physically when someone can just be following you at night, looking at where you are going to enter, so that he can get access or see how usually maybe type a password to a wall. Let me say all those security doors that have the passwords or the devices on the wall where you have to type the password before the door opens. They can just be spying on you from one end and look at the password you're pressing. Another one is something for something, quid pro quo. Okay, so this is when an attacker requests personal information from a party in exchange for what? Something else. So Wi-Fi password cracking. This is just a way of discovering your Wi-Fi password, and this can be done by social engineering. Okay, this is when the attacker manipulates you to giving him the Wi-Fi password. Another one is brute force attack. So this is when an attacker tries several passwords, many passwords, until the correct one works. Now, this is easy. This brute force attack is easier when the password is only a combination of numbers. Okay, let's say they know that it's 4 digits, so they just start trying all numbers from 0001 to 9999. So if you have your password is about 4 digits, it means that your password must be between 0001 or 0000 to 99999. So they'll just keep on testing everything until they get your actual password. I had an incident. You know all these Ecolab boxes that have passcodes to lock the zip to some kind of padlock that is embedded on the box. So I forgot the passcode for unlocking my zip. So I have to start from the beginning. Start from 000 and start going to 0100 to 003 until I got to the password. So that's an example of a brute force attack. Another is network sniffing. So the password may be discovered by listening and capturing packets that are sent on the network. We're going to do this particular practical. I'm going to show you how to use something like the packet sniffer to um, to steal or collect passwords that are of people that are on the network. You know, when you don't use things like a VPN, you're actually naked on the network. So everything that you're doing is going to be visible on the network. So attackers can just use packet sniffer to check you out. Then we have phishing. This is when malicious party sends a fraudulent email disguising as being from a legitimate, trusted source. So you might get an email from your organization, but if you check the email well, you see that it's not actually from your organization. So that's an example of phishing attack. Yes, fair phishing is when a person is being targeted. In phishing, there can be multiple targets, but fair phishing is that it's targeting a particular person. Next, we have vulnerability exploitation. So vulnerability exploitation is when an attacker, maybe scans to find vulnerability on a system to exploit. So the first step it does is that it gathers information about the target system, probably a website or an organization, okay, using port scanners or social engineering, interrogating different staffs just to get some information. Next step is that it determines the length information from step one. Okay, he uses every information as gathered to check for vulnerability. In step three, that's when he looks for the vulnerability. In step four, now he now uses that known vulnerability, okay, to write a new exploit. Another vulnerability exploitation is advanced persistence threat. So this is a multiple phase, long-term, stealthy, and advanced operation against a specific target, and it's usually well funded, and it deploys customized malware. Denial of service. Denial of service is a destruction of network services. Okay, so it could be as a result of overwhelming quantity of traffic. Now, this is when a network post application is sent an enormous quantity of data at a rate which it cannot handle. So thereby, that network is automatically shut down. Another one is maliciously formatted packets. So maliciously formatted packets is sent to a host or application, and the receiver is unable to handle it, and probably that person's system, shuts down. So here is an example of that. So let's say this is someone visiting a website, a DOS attacker, who sent several pings to the internet, to the web server, which the person is requesting. So the person is visiting a website, and this web server is giving the person whatever he's viewing. And the person now requests for a new page, probably by clicking the home page. So the home page takes time to do because the web server is busy processing everything or every packet that this attacker is sending to the web server. That's how the web works. Okay. For you to access a website means that the web server is somewhere giving you everything they are requesting for from the website. Now we have DDoS. This is distributed denial of service. So it's similar to DOS, okay? It's similar to DOS, but in this time around, it is from multiple and coordinated sources. So what can be used is a botnet or zombie. So it infects hosts. So when an attacker sends those malicious packets to different people, okay, before you know it, their systems become very slow and you're unable to access the web server. So the zombies are controlled by handler systems, and the zombies continue to infect more hosts, creating more zombies, just like that. So we have SEO poisoning, that's search engine optimization poisoning. So it is a technique that is to improve. So SEO is actually a technique to improve a website's ranking by search engine. For example, you search cybersecurity, and the first thing you see is what Spotnet Hub. So now that means Spotnet Hub have done an SEO on their website, all right? So they are now ranking high on the Google search. So when an attacker carries out SEO poisoning, okay, you now see a malicious website. Now, when you search cybersecurity, you see a malicious website rather as the first option on the Google search. So that is because an SEO poisoning has been carried out. Now, the cybersecurity landscape. There's something called blended attacks. Blended attack. So a blended attack is the use of what multiple techniques to compromise a target. So the person could use um, worms and Trojan horses, or Trojan horses and spyware, keyloggers and Trojan horses, phishing schemes and worms to carry out an attack. So common blended attack example is this now: spam email messaging, instant messaging, or legitimate websites to distribute links. So DDoS combined with those phishing emails. You can see that. So how does that work? So the person can just be sending unlimited packets to a web server, and the person now sends mails to the person in order to infect the person with a worm, so that the person's laptop becomes very slow. And at the same time, using the slow laptop, the person can also not access the website that he wants to access. And examples of this were Ninja attack, the code red attack, the bug bear, chaos, slammer, Zeus, and Conflict. So what is impact reduction? So it is used to communicate the issue, all right? Impact reduction communicates the issue, okay? To reduce impact again, you have to be sincere and accountable, all right? You also have to provide proper details, okay, of the situation of what you are passing through. So when I say proper details, it means that how did you start experiencing, how did your system begin to get slow? Or when did you start to experience that your system was slow? When did you start to know or understand that your system was slowing down? Because you now be like, okay, it was after I visited this website, or after I downloaded a particular application, my laptop became very slow. So from there, an ethical hacker will be able to troubleshoot your situation. Also, take steps to avoid another similar breach in the future. So which means such websites that you visited, you should not visit them again. Or such applications should not be downloaded from those illegal websites again. To ensure all systems are clean, educate employees, patterns, partners, and customers of cybersecurity. So it means most organizations do not usually educate their staff on cybersecurity um, information or cybersecurity generally. But if staffs are properly educated on this, there are some attacks that would never even happen in the first place because a staff would not make such foolish mistake. For example, plugging a flash drive that you saw on the road or you saw on your desk, on your laptop, on your company laptop when you do not know who has the flash drive or you do not know who gets the flash drive. That's a foolish mistake that can be made by a staff, a company staff. And that's because he does not know, he has no knowledge about cybersecurity. All right. So finally comes to an end in this chapter. So I'm going to stop presenting my screen now. We've identified the example of security vulnerabilities, explain how a security vulnerability is exploited, describe type of malware and their symptoms, and understood what blended attack is. So now I'm going to be here. You have my screen. So I want to show you how to access the task manager. There are two ways. You can come to your start menu and you can type task manager. So you can see task manager here, or you can right click on your taskbar and you see task manager. Now, I was talking about something when you have something like a denial of service attack, or when you start to experience that your system is slowing down. When you start to experience that your system is slowing down, you could come straight to your task manager like so. Okay, I begin to look at your memory. Now, my memory is my RAM, and it carries information of how many applications or the applications that are running. Now, by the time I click on this icon here, I'm going to make this large so that everybody can see. Okay. So if I should sort display my processes by memory, you would find out that what is consuming much memory in my laptop at the moment is my Chrome. Okay, and it has about 57 tabs currently open. It's funny, right? I open a lot of tabs, and that is consuming about 1.9 gig of RAM. All right. I also have Microsoft Edge open. Okay, and I have about 19 tabs. All right. Just like someone is trying to join. I'd like to check that out. Okay. So I have about 19 tabs open or 19 processes running on my Microsoft Edge. So it's consuming about 219, 92.2 MB. So when my system is slowing down, for example, my system is not actually slowing down because it's working optimally. You can see my CPU usage is just with 1%. So just with 1% or to 70% of my CPU is being used at the moment. And my memory, just my RAM is just about 54% that is being used. So if I should check my network now, network actually is like your data connection, all right? So my data connection now, what is actually consuming data on my device, on my laptop at the moment, is my Chrome, and that's because I'm running Google Meet on my Chrome. So you can see it's running at 0.5 MB per second. All right. So I'm not doing anything on my Microsoft Edge. You can see it's on zero. My Slack is running on the background. You can see that's why this icon is there. It's running on the background. Okay, and it's consuming small amount of data. I also have my anti-malware service running. So this is where you come to check for processes that are running that will be slowing your system down. If you come here and you see that your memory is at 100 or your CPU is running at 100, when your CPU is at 100, your CPU or your system fan begin to blow vigorously and you begin so much sound from your hardware. When it's at 100, your system will become very, very slow. Your disk now, on the other hand, is your hard drive. So when your hard drive, this amount of space or storage that is being filled on my hard drive or being used at the moment on my hard drive. So it's always good to have a lot of space on your hard drive before running any task.